Today, we are diving into the heart of modern industry to explore the incredible technology that are revolutionizing blast furnace iron making. In a world of volatile prices and strict environmental law, the pressure is on to make iron production more efficient, sustainable, and long lasting than ever before. So let's see how modern engineering is meeting this challenge head on. So, what are the biggest hurdle for today blast furnace? There are four key drivers for innovation. First, minimizing coke consumption. Coke is the most expensive raw material, sometimes accounting for over 80% of the cost to produce hot metal. So, reducing it is a top priority. Second, extending the furnace campaign life. The goal for modern blast furnace to operate continuously for 15 to 20 years or even longer without a major shutdown. Third, maximizing availability with fewer furnaces at most plants, minimizing downtime for repairs and reline is absolutely critical to staying competitive. And finally, furnace must adapt to lower quality raw material while maintaining a stable and efficient operation. The foundation of a long lasting furnace is its lining and cooling system. One of the most successful modern decision is the Hugoven system, which uses machined copper plate coolers paired with high conductivity material like graphite and silicon carbide. This design is a true marathon runner, with some furnaces achieving campaign life of up to 25 years, even under the stress of high productivity. How does it work? The highly conductive lining encourage the formation of a stable protective layer of certified material called an accretion layer. This layer acts as a natural shield, making the furnace incredibly resilient to high heat load and erosion. While another design using copper stiff exists, it has faced significant issues with a catastrophic abrasion failure, making the Hugoman's concept a more reliable choice for long term and high intensity operation. When a furnace finally does need a reline, speed is everything. That is where modular construction comes in, and it's a game changer for minimizing production loss. Instead of building the furnace piece by piece on site, huge section or modules are pre-assembled elsewhere, complete with the cooling system and refractory lining already installed. Then using advanced heavy lifting system, the old sections are removed and the new ones are slotted into place. The result, a full reline that used to take over 120 days can now be completed in less than 70 days. A partial reline can be done in just 40. This technology has even been adapted for the robust Hugoven design, making it faster to install than ever before. Now let's talk about the cost. High pulverized coal injection or PCI is a cornerstone of modern low cost iron production. The main goal is simple: replace expensive metallurgical coke with a cheaper pulverized coal. Modern system can inject over 200 kilograms of coal for every ton of hot metal produced, cutting coke consumption significantly. But this high injection rate puts a lot of stress on the furnace, demanding a robust lining and cooling system that can handle high heat load and potential instability. The benefits go beyond cost saving. High PCI allows for higher oxygen enrichment, which boosts productivity. It also increases the energy content of the furnace top gas, which can then be used to generate power elsewhere in the plant. Now, one of the most exciting recent innovation is the SIP, or this world first technology installed in Germany enhance both efficiency and the stability. Here the here's is how it works. In addition to the normal continuous oxygen flow, SIP injects short, high energy, supersonic pulse of oxygen periodically into the furnace. These pulses enlarge the raceway, the combustion zone in front of the nozzles, or 2 years, which dramatically improve the gas permeability through the center of the furnace. The results are impressive. Better gas flow leads to higher efficiency, which lowers the total fuel needed and can reduce CO2 emission by 50 to 100 kilograms per ton of hot metal. Crucially, SIP has also proven to stabilize the process when using poor quality raw material, allowing for continued production when other furnaces might struggle. So, the future of blast furnace iron making is not about a single magic bullet. It is about an integrated suite of technologies working together. Long life design provides reliability, modular construction maximizes availability, and high PCI and innovations like SIP reduce cost and environmental impact. Together, these advancements ensure that blast furnaces remain highly efficient and competitive route for making iron for years to come.